forward to this computer. Okay, so let's get going on our modeling. So if you go to AnyLogic, we're gonna go and I just want to orient you again. Here's the projects window. This is gonna show for one or more projects a hierarchical view of the projects. The palette is going to have various components that we can drag onto canvases. Those canvases will be associated with the different subcomponents of a model. So we could be editing an agent and such as person, and there'll be a canvas, and we could drag things onto the canvas. We could be editing main and drag things onto that canvas. We could be editing a scenario and drag things onto that canvas. The palette gives the building blocks, but much of the art of AnyLogic modeling is how you hitch up those building blocks. And I'm going to be speaking with emphasis. Beyond that, we have a properties window, which gives the properties of whatever's selected right now. And there's a console, which provides output, as well as a set of other menus, such as problems to tell you issues with your model, search for search results for your model, and a set of other components as well. Okay. So let's get going with actually building up our first little model in AnyLogic. So we're going to do File, New, Model, and it's going to be my first AnyLogic ABM. Okay. And I'm going to call it V1. No, we're going to actually go somewhere with this. So let's do it. ABM SEIR V1. Okay, version 1. It's important to keep versions. And notice I'm using underbars between these things, and not dashes, underbars. Importantly, you have to set model time units. Be careful with this. It behooves you to be careful about what your time units are. The time units actually don't themselves change how fast the model goes. In other words, how it doesn't directly impact. It's not like a model in milliseconds grinds along slowly compared to a model in years. It's just that if you're not artful in choosing this, you may find that later you come back and you want to change it, and it's a hassle because your charts are set to go off every millisecond, and you later want to make the model in years. Really, what this tells you is, what does 1 unit of time really mean? Is it 1 year, 1 second, 1 millisecond, 1 month, 1 week, 1 day? So we're going to be choosing days here. Okay, days. Because we're going to be dealing where days are most natural form of specification. So we're going to say days. We're going to say finish here. Okay. So what did I do? I did File, New, Model. I filled in the name, and I chose days, and I said finish for anyone who didn't follow it. Okay. Great. So you'll notice when I created the model, it has a thing called main. Main basically provides the overall global environment, the global environment for the model. The overall overarching stage in which agents are going to strut, the highest level context of the model. And it turns out main will provide the basis for running the model. And by giving main different assumptions in the form of parameters, we're going to be able to run the model with different scenarios. This X is an indication of a scenario. Right now, it doesn't specify any parameters. It doesn't need to, because main doesn't have parameters. But its job in life is to kick off a running instance of main, to run main. And that's why we can, for example, right-click run on it. And if we run this, we will see nothing of particular interest. We will see a model which says running, and time is moving on, but there's really nothing of substance happening because there's no processes characterized. There's no people. It's an empty world. There's nothing of substance. But that's how you'd run it. You'd right click on this and say run, and here we are with main. Now we want to add some process to this model. So let's go add some theory of personhood, some theory of what it means to be a person in this model. So if you do this, you can right click on the model, say new agent type. Okay, so I'm noticing clicking on right click on the model and saying new agent type. I can't remember on a Mac if it's command click or option click or what, but it's one of those, I think. And I'm going to say new action type or new agent. Okay. This agent is going to be a person. So I'm going to say person, capital P-E-R, capital P, person. Okay. This is going to be, we're going to represent a theory of personhood. Okay. Person, and I'm going to say finish. Okay. And it's going to be a person. Okay. I can double click on person. And what I'll see is there's kind of a vacuous theory of personhood, trivial theory of personhood. There's nothing there right now. Okay. Let's give this person a face upon the world. So we're going to go to palette. And note that this is the first time we've done anything from palette. And I'm going to give this person a visualization. It's important that I do it before adding a population. You can do this after I create a population of these people, but it's a little bit more involved. So it's better to do up front. So here we go. Here's a palette, okay? And we're going to go to the agent, we're going to go to the presentation palette. We have many possible palettes. We're going to go to presentation. We're going to draw in an oval. We're going to click and drag in an oval. And at first it'll be a rather big oval, but we're going to sort of squeeze it down and center it. Now, that involved quite a bit of sort of futzing visually. Possibly a better option is once you've added that option in. So again, I went to this palette and I dragged in an oval into person. Make sure you drag into person. Dragging into person is very different from main. If you dragged in the oval into main, it would say there's one oval to rule them all for all of the model. You know, there's one oval in the overall situation of the model. Dragging into main means each person has an oval. It's part of the theory of personhood. Persons have a face upon the world. That happens to be an oval. Okay. So I dragged into oval into person. By clicking on it, I can actually go over here in properties because I've selected it. I can go in properties and I can fob things here. For example, I can select it and I could say I want it to be a radius of, let's say 5, or I want it to be a radius of 10, right? And I could also even position it through that. So in general, we have the option of manipulating many things visually, but we also have the option of manipulating them through this properties window, okay? And you'll see me sometimes, you know, edit things over here by going and opening things up and clicking here and editing them in the properties, or you'll see me editing them here by clicking on them. These are two different ways to access it, through this projects window or through this by selecting it right here on the canvas. Everything that's in this model is represented in this projects window. So this small oval is inside a person in the presentation properties, but I can also access many of them here in this palette. You know, it's these connections, to which we'll be returning later, are also in this window. So there's kind of this parallel hierarchy. Okay, or this parallel worlds. This is kind of more flat and you can access these things. This allows it to be accessed in sort of a hierarchical way. Okay, so here we are, a radius of 10. Each person has a radius of 10. Okay, So that's great. We have a theory of personhood and involves a single attribute, a single characteristic of that person, which is a circle. You could think of it as each person as a parameter that represents a circle, if you want, their visual representation. Now we can go back to the model and we could run it, but we won't see anything different because we've described the theory of personhood, but there's no population of people. There's no collection of people. There's a kind of a disconnected theory of what it means to be a person, but there's no population. So let's go add a population. So we're going to go to main, and we're going to add in a population. Let me tell you where I'm going with this. I want a model which has people in the environment, and there's interactions between the people that can communicate infection, transmit infection from one person to another for this model. We're going to be getting to some chronic disease later, behavioral factors, but in the other model, but that's where we are right now. And if I want to move towards that, I need some collection. You may recall agent-based modeling has a variety of pieces for an agent-based model. We when I first described what are agent-based models in my ABM overview, one of the things I described was that they include representation of one or more populations. I'll actually pull the slides up because it will have some additional helpful components on it. So here we go. I'll drag it in here. You may remember these slides. One or more populations composed of individual agents, each associated with parameters. We could think of that circle as kind of a graphical parameter. And we're going to be filling in the rest of these shortly. But right now, there's zero populations, not one or more. This isn't really a full agent-based model yet. So let's go add an agent-based model. We need a population. How do we have a theory of personhood. That's great. Particularly simple theory right now. We'll be elaborating it, but we have no population of people. Let's go add a population. Now this next component, I want you to watch carefully. To add a population of people to main, the easiest way to do it is to go over here in the projects window, click on the agent class here. This is the agent class. This is the theory of the thing representing the theory of personhood. And when main is selected, we want it to be the population to live in main. We're going to drag it in here. Drag it in. Okay. So I clicked on this and I dragged over. And I'm going to call this population. But as I said before, I could have just left it its original name, person, clicked on this and typed population over here in the properties window. Maybe your properties doesn't appear here. Maybe it appears, for example, down below, or maybe it appears here. You can set where these things appear by clicking on this and kind of dragging it around and placing it in various locations. If it disappears, you can always get it back with this. If you get rid of properties, where's my properties window? Well, you can get it back with this. Boom. Just by clicking it here. So don't worry too much that it could disappear or something. But you can get it in various places. You can even have it stand alone by itself if you want. Okay. So here's this population, but it's not really a population yet. It's a single agent still. We have to select population of agents. And now it's going to ask us very obligingly, how many agents are there? Well, let's leave it at 100 for now. Let's just leave it at 100. Okay. So what did I do? I clicked on this. I dragged it in here. I want to create, right? I want to be true to this, one or more populations. So for the overall model in main, I want to drag in a population, and it's a population of persons whose theory of personhood I specified here. And by dragging it in, click, drag and drop, then I basically say it's a population of agents. Initially, it includes 100 agents. We could also have it loaded from a database or start it empty, but I'm going to start with this. Great. So now we have one or more population of agents. So we have agents with parameters. So let's run it. Let's run this. Okay, run. I'm going to right-click on simulation and say run. Here we go. And there it is, a population of 100 people. I can even go look here, go into this menu here, and I can go look, and I say, oh, there's a population of 100, and I can go person by person. Here's the first population. Look at that. They have a little circle here. Here's the second person. Look at that. They have a little circle. Here's the third person. Look at that. They have a third circle. Okay, well, now we have a population of people, at least. They all look the same. There's really no distinction among them. So let's start giving them some distinctions, as it were. Okay. What we're going to do is first, we're going to situate them in the environment. Okay. So we're placing them in an environment, and particularly a spatial environment. I'm going to scatter them around the environment. Okay. This person is going to be placed at a random location. This is an aspect of their parameters. We could think of it as parameter, sort of assumption about where they are in some fixed way in the environment. But it's a particular type of one we can specify easily in any logic declaratively, so without writing code. So we go to main, we go here in main, and in main you can drag down. Here we go. And we can go specifically to this space and networks area. Okay. And in the space and networks area, you'll notice that we can specify networks. We'll be getting to that, but layout types. And we could choose a random layout. And that's one option. I'll show you two ways of doing this. This is one option. It's declarative. It'll get you where you need to go for random layout for a simple case. So where did I go? I went to main. And in main, the properties, these things reflect what populations in main, the rules by which populations in main live. What's the space, width, and height in which they live? Is it discrete or continuous space? Is it a set of grid cells or a continuous space? Is it a GIS space? But we're going to set it to be a layout type random. Don't do GIS lightly. It's going to be we're going to set it to be a random layout. So we're going to place them at random places. So if you want to just get started quickly, you could do this. We'll place these folks at random locations, and there they go. And now we have people at different locations. This population of 100 people is located in different places here. Okay. They're located around the space in different places. Okay. So that's one way that we can lend people spatial differences by saying, place them at random locations. But the truth is, it isn't very versatile. It isn't very flexible. You can kind of say user defined. You can put it arranged in a grid, for example. If we put it in a grid, we could say, okay, we want to see them, in a sort of stacked way and place them all there before us. Maybe we want to see them just laid out as to, which is in which situation. And there's a couple of others, and they're okay. But, a lot of the time we're interested in doing something a little bit different. Now, so I'm going to go back to main and change it. Now, remember, it's very important when you're using these models to be conscious of what you're looking at. I'm looking at main, and I'm editing properties in main. Other times I'm going to be editing person, for example, and editing parameters in person. And it's important to be clear, what I'm looking at in this canvas. If you drag things into the wrong place in the canvas, the wrong agent, you're going to be in trouble. Okay. So when I say you're in trouble, it's not going to work as you intended. So it behooves you to be really conscious about what you're looking at right now. And when you're dragging something in, make sure you're dragging it into the right one of these. We're going to go to main because we're setting the features for populations in main. We had set it originally, it was originally user defined, and then we set it to random. We could do ring, and place them in a ring network. This is kind of nifty if we want to see infection propagate around a ring. But I want to show you something more flexible than that, because we're going to be big boys and girls by the time we're done with this session. And so we're going to go to main, scroll down, and we're setting the type of environment in which all populations in main are subjected. And I'm going to set it back to user defined. And that may be a letdown because you like those nifty layouts, but we have a better thing. We have, we don't have to eat kids' fare. We can make use of, those are nice for, quick trials of things. But if you want flexibility, I'll show you how to get flexibility. Okay. So to get more flexibility, we're not going to be dealing with things for every population in here. We'll be dealing with on a per population basis. We'll click on this population and we'll say, hey, for this population, we want to place people at certain places. So we're going to say in the specified point. You notice I can choose where to place them. Now you might think, well, wait a minute. I can type in different numbers here, but they're going to be all the same for all the agents here. No, because I can put in general rules. And in fact, this little light bulb is giving you some hints of things you can use to sort of extra information it can give you. But for now, maybe I'll say we'll place it, in a location that is uniform between 0.0 and 500.0. Okay, we'll come back to this in later, but I'll just lay them out randomly, but we will draw. So this is a bit of Java code. You're saying, call this thing that says, give me a uniformly distributed value between 0 and 500. Notice there's no semicolon. A semicolon isn't needed here. This is saying, compute me a value. It's what's called an expression. It's like a formula. It says, compute me this value. So there's no semicolon. We'll see semicolons later. And we'll see that they're needed for commands. Say, do this, a so-called statement. This is something which computes a value. It's like a formula in Excel. It computes a value. So you don't need that. What sort of coordinates do X, Y, Z? So X is going to be along the horizontal plane, Y vertically, and Z will be in and out of the screen. Okay. So you can actually have Z coordinates. You can have one agent above another. Probably for your needs, it's not going to be a big need, but if you were simulating mosquito flight and egg laying and along lakeshore margins, maybe there's something there. Or if you want to simulate some sort of 3D space involving transmission of aerosols. Maybe there'd be a need there as well. Okay. So we're going to only really use X and Y. Okay. Now I'm going to run this thing. I'm going to leave Z unmodified. I'm going to run this. Right click on simulation to say run, and we will see, lo and behold, we're back to our sort of random layout. Okay, well, that's okay. Not too bad. But let's do something more interesting. Okay, so you'll notice in my comments earlier, I said that kind of the circle for a person was kind of a parameter. It's kind of an assumption. Everyone has a face on the world that happens to be the same. But let's start learning more about parameters, okay? And I'm going to, this says one or more populations each, ladies and gentlemen, each associated with parameters, okay? As well as state. So let's add a parameter in to this. But, you know, I'm conscious of the fact that we've come a certain distance already. Maybe some of you are lost. Maybe some of you want to catch up. And, you know, conscious of that, mindful of that, I'm just going to go over. And in this other window, I want to go add in, and pardon me, I'm just going to go add this model to the class site here. And where is my, here it is. Okay, good. So I'm going to start my screen sharing again. Well, we don't need to do that. I'll just drag this in. So I'm going to take this model that I've been building, and I will place it on the course site in that models built in class. Okay. So here we go. And there it's posted, ABM SEIR V1. If anyone wants it, go and get it. Okay, it's there. And reflective of that, I'm going to save it to version 2 so we could continue on. But Jabba has a question. Yes.
Hi, Nate. So I saw one question in the chat room, and also that's also my question. So Amarita asked, what sort of coordinates do X, Y, and Z specify?
Yeah, I tried to say, you know, X is along the screen, Y is vertical, Z is in and out. But maybe the question is more, like, is it in meters? Is it in centimeters? Is it in kilometers? Maybe when we say sort of coordinates, you know, it's a spatial measure. And is that, are you wondering like about what units the measure is in? Like, is it in meters or centimeters or what? Is that what the question is? Or what sort of information are you, when you say what sort of coordinates, what are you looking for? Polar versus Cartesian or what?
So for me, my question is, the picture it shows seems like to be 2-dimensional, and then when it comes to a Z, so am I thinking like a 3D or something?
Yeah, you are thinking 3D, and what I'm saying is that there are models that have 3D components, and you can find them in your in the example models. There are models that involve 3D structures, which can allow for simulation of certain types of sort of processes in complex environments. I remember there's one like it involves a factory, and you're producing you know, producing things within a factory, manufacturing et cetera. And some of these actually have 3D space. And like that's something where like a third dimension might be useful. So here's like a steel converter process. I think it involves like where you have a three-dimensional environment for constructing in a factory for building things. This is unlikely to be as relevant in healthcare, but as I said, like if you were simulating the spread of aerosols, or I don't know, a multi-level structure for a train station and simulating people moving up and down escalators, and I was involved in a model like this for a Chinese train station, the spread of COVID-19 in the Chinese train station. So this is a 3D model, right? It involves like picking things up and transporting them. So some work is going on at this upper level, some work is going on at the lower level. To be honest, I have not really made serious use of this in a health context, except in that Chinese train station example where we were simulating the spread of infection in a 3D environment. So yeah, I find 99% of our models don't need the Z direction. It's basically a flat environment. But for some sorts of needs people might undertake, it could be useful. I don't know if that's helpful comments. Yeah, for 2D for 2D modeling, X and Y are enough. Z is for just if you want to tap 3D. Yeah. So maybe you're interested in spread of aerosols from COVID-19 in a football stadium, or in a theater with balconies, right? So you have people upstairs and people downstairs, and some of the aerosols circulate and come from downstairs to upstairs and vice versa. And, you could do it with 3D. It's a fairly involved process. In other words, like you really want to know what you're doing with that. But you could do it, and people might be located close to each other because one is located just above another with an airspace between them or something like that. Yeah, it tends not to be used all that much in the health side, but could be, for specialized situations. I have built 3D models, or I have built models of like spatial models of spread of COVID-19 in movie theaters versus a stadium versus a restaurant. And there, maybe 3D is needed for some restaurant layouts or some, theater layouts. Yeah. Okay. Any other questions? Notice I saved mine as version 2. We're going to be working on for version 2 now going forward. And then I'll save post version 2 and we'll go to version 3. This is a best practice, saving successive versions of your model with different version numbers. So you can always go back to the one that was used to create certain results. Okay. So we're in version 2. If anyone needs to download version 1, it's there. Okay. So now let's give people a little bit more texture. Let's take each person and let's give them, this is a pretty impoverished theory of personhood. Let's give them something which, lend some heterogeneity to them. Maybe we'll give them, for example, an income. Okay. So we'll go here. We'll go to the agent palette. So, okay, we're going to give them an income, and we're going to have heterogeneity in the income across the population. That's what we're going here. And the income will affect their location in space. Okay. So we're going to go to agent and the agent palette, because that's where parameter lives. We use parameters to encode the assumptions about people, okay? And here we're going to have people at different incomes that we're first going to build, and then we're going to lay them out with sort of different locations in space based on their incomes. Okay, great. Now let's go take a look at this. Okay, so I want to go drag a parameter into person. A person will have a characteristic, and we encode a fixed characteristic with a parameter. A parameter serves two roles in any logic. I'm addressing some of the questions. Parameter serves two roles in any logic. It encodes a typically fixed assumption, and number two, it communicates the assumption to be used from the point of creation of that agent or that structure to where it's needed. So it serves as a communication vehicle and to encode an assumption. So with the person, we're going to have an income. How did I do that? Whoa, I dragged from the palette, I dragged parameter into person, and I called that income. And when we create a parameter, we have to specify its type. I'm going to say double, okay? And I'm going to give it a value if there's no other rule for it given, give it a monthly income. It would be better to say maybe maybe I'll say annual income. It's often good to give names that connote sort of when they're per unit time, it connotes sort of, are you talking annual? Are you talking monthly, daily? What? I'm gonna say annual income. Okay. And maybe I'll say, $25,000 per year, if nothing is specified. Notice I'm being a little bit careful with putting like .0. You want to be a bit careful in Java. Any logic is based in Java, and you want to be careful because there's actually a difference between this and the value of 0.0. It interprets this as an integer, and that's not a problem generally. Generally, it will transparently convert it to a double, but you have to be careful if you divide it by another integer because it'll perform integer division. So if it's not divisible by 3, for example, it'll give the nearest one it is divisible by. It won't return a fractional number. It'll return an integer. And generally, you don't want that. Generally, unless you want that in very particular cases, you can use it, but otherwise, we like to use doubles for capturing sort of fractional quantities. Okay, so here we have income. So each person now has sort of two characteristics, two parameters, as it were. Where are my slides here? One is their income, and one is kind of they have a face, they have a characteristic that's fixed as well. Okay, great. So if we were to run this, run your models early and often. Run them early and often. If we were to run it, we would find that people are laid out in space as before. Woo. And if we were to go look at each person in the population, we'd find they all, not surprisingly, have an income of 25,000 because we haven't specified any differences. It's the default value. In person, when we dragged from the palette the parameter in, we said its default value, if we don't specify anywhere else, is 25,000. And so it dutifully used 25,000. But we want heterogeneity. I mean, one of the foremost strengths of agent-based modeling is we can support rich heterogeneity between agents. Where do we do that? Well, we generally have heterogeneity not in our theory of agenthood, but across a population. So maybe the income distribution will be different for a rural town than it would be for a big city, different yet than from what would be for a certain neighborhood. So often our populations in any logic, our populations serve as kind of the construct on which we impose assumptions about parameters of the agents in them. So we have populations, and these agents have parameters, and in any logic, the population, the notion of the population, this thing we have in main, has the assumption, specifies what to assume about the parameters of the agent in that population. So this is a population in main. It's called population. We could have several populations in main. You know, population of rural town and major city. It could be two different populations. Each of them would allow us to specify, hey, what do we want to give for the income for that population? And of course, here it is a fixed value, the one we said, but in general, we don't want a fixed value. We want a value that's going to be heterogeneous. Okay, so what do we do? We could say, well, we'll have we'll have this drawn from a log normal distribution, okay? And the log normal distribution will reflect the fact that there are many people with lower incomes, but there's a long tail on the upper side, okay? So here we go. So for the population annual income, we're going to give a rule. We're going to give a formula, an expression, as it's called. And this will be run for each and every one of the agents in this population. When they get created, we're going to run this formula. Remember, I told you, parameters serve two purposes. One is to encode an assumption here about a person. We'll see that parameters can be used for other things too. But here it's coded the assumptions about this agent. That's one thing. But the second is to communicate that assumption from the point of creation to that agent. The point of creation of these persons is the population in which they live. That's what creates them right now. So we're going to say, we're going to give a formula that will tell what rule to use to determine their income for a given person in this population. We're going to say log normal. This is just a draw from a distribution. Nothing fancy here. It's a draw from a distribution with, and by the way, we could start typing it out, but in any logic, it's much more convenient if you use autocomplete, because some of these names can be kind of long. So if you do, well, on PCs and Linux, it's control space. It'll actually fill out the options for this. On Mac, it's, I don't know, option space or shift space or control space or something. I don't know. Wade is currently in the breakout room. There's some way to get it to start type this out for you. So you can start typing it, and control space or whatever the key is on the Mac will fill it out. And it's we specify the log mean, log standard deviation, and we can optionally specify a minimum value as well, or we could specify minimum. So we'll say log normal, and we'll say let's say 10 will be the value for log mean. Forgive me, this is for mu, and log sigma, or sorry, log standard deviation will be 3.5, and the minimum will be 0. Okay, so this is specifying their income as a draw from this distribution. So for each person in this population, it will draw from the distribution their income. This is the rule. This is the formula used when each person is created within the population. It'll run this formula to determine what their income will be, to set their parameter and communicate it to the person. Remember, I told you, parameters serve two purposes: to encode an assumption and to communicate that assumption from the point of creation where it is. Any parameter in person will be something that you can specify here what rule to use for people in this population. If we had a different population, we could use a different rule for it. Okay. Thank you. Option plus space on Mac to fill this out. Autocomplete is your friend. Autocomplete early and often. It'll prevent silly spelling mistakes. And it tells you what it wants. If you start typing here, log normal, it tells you, so keep on typing log normal. There are two things. I pressed enter to see the two things, and it tells you what it wants, and it tells you what it does, generates a sample from the log normal distribution. Okay, there we go. Now, for the case of parameters, there's actually a thing up here that you can click on. You have to be in one of these places where you can type code. If you want more help, you can click here, and it shows you all sorts of parameter distributions that it allows, and allows you to experiment with them and see what they look like for different parameters. You know, if I change this from that to that or that to that, see what they look like. And again, to see that, you have to be in one of these code areas, and you could press this choose probability distribution. But anyway, we specified a rule that applies for every person in this population. Every agent in the population will specify assumptions about its parameter. Each person has an income, and it's at the population level or wherever the agents are created that we specify its assumptions. Later, we'll see if we have to specify when they come into the population too, dynamically. Here we go. Okay. So let's run this model. Run early, run often. Let's go do it. So we go to projects. By the way, this model's getting more complicated, so I'm going to press this build thing here. Build's going to make sure it understands my model. It's by pressing this build thing up here with sort of ones and zeros on it that I'm sure it says we're communicating okay, right? You understand what I mean. You understand what I'm telling you. And really, it's telling us, is what you've told it grammatical? Does it understand the structure? It may not be what you want it to be. The semantics may be different. Maybe you think it means one thing when it means another, but it's at least telling you, oh yeah, look, what you're telling me is grammatical. I understand what you're saying. Yeah, okay. So that means it can run it. So if it says build completed successfully, you're golden to run it. So if you right click on this and say run, you will now see people. Okay, here are people in the population. Yeah, okay. People are in the population. Great. But let's go look at the population, and we can drill down each of these 100 people, and we'll see, oh, this person has a $5 million annual income. This person has a lower income. They're not a person of means. The third person here has an income also on the lower side. This next person up also on the lower side. Next person up also lower. Most are low, but this person is in the six figures. So I'm scrolling up here, and what we're seeing is people are variables. They have different incomes, right? Okay, so we have a heterogeneous population, not only in location. That was something we said, well, for the population, we set their X and Y position to draw from this, but now we set their income. Okay, ladies and gentlemen. Great. Okay. So here we're going to go and I think I'll post this model so you can see this, and we'll go on to version 3. So I'm gonna post this to the site. If anyone's falling behind, you can grab it from the course site, and we will continue on. So I will post version 2. Here we go. Boom. It's up there if anyone wants to grab it. Any questions about what I'm doing so far? Any questions? So far, we have a heterogeneous population. Questions? No? Okay. Okay. Great. Okay. So let's go and right. Excellent, excellent, excellent. Okay. What we're going to do is I'm trying to design this uniquely for you, so I'm ad-libbing a lot here. We're gonna go to main, and now we're going to make their location depend on their income. Remember, I told you these things in main, space and networks, you can kind of use the basics, a ring, a range, random. But if you really want flexibility, you want to specify it at a population level. And we went and we did this. We put in this uniform thing. But really, I mean, we didn't do much different than just saying uniform. So let's now take advantage of this, if we may. Okay, so ladies and gentlemen, for their X location, I want to put their income. Now, if we use their income directly, you're going to have people like an annual income, you're going to have them like way out to the right. Or if they have $1 million income, right? And then you're going to have some people with like tiny incomes. We're going to have to finesse this. I haven't done this before, so what the heck? We'll say their X location is given by, and I'm going to say self.income, okay? Now, you may wonder where I got this self thing. There's a little thing here that it's a light bulb. And you'll notice it says self at the end. So this allows us to refer. It's only active when we're creating the person from the start. Okay, there's another context in a totally different place where it's that word happens to be used self, but really there's nothing about Java. It's just any logic when you're creating the person allows you to refer to these things by doing self dot and I'm going to say annual income. So I can refer to my characteristics when I set my X location. Notice I do this dot. This is kind of like an apostrophe. If any of you have seen, Python or Java or C++, you probably recognize this. This dot means like look for the annual income in myself. But it's kind of like, for those who haven't seen that before, it's kind of like self's annual income, something like that, but it's with a dot. And you can see it fills it out. Dot annual income, it lets you refer to it. So I'm going to say their X location is given by their annual income. But this is going to cause some pretty weird stuff visually, because there's going to be like people like way the heck out there. So let's try it. Self.annual income, and we'll do run. Here we go. And you'll see people here, and you could scroll, and people will be way out here with higher and higher incomes. So I want to compress them some. I want to sort of have them squeezed in here some, okay? So I'm going to, instead of saying just self.annual income, I'm going to say divided by 1,000. Now I could take the log of it. That wouldn't be a log and then times something. There's various ways you could do this. I'm gonna see, I'm ad-libbing here, but I'm gonna say self.annual income divided by 1,000. So some people are gonna be really squeezed over in the left, and others gonna be, sort of spaced out there to the right. There we go. See them? Who do you think these people are here? Anyone? I'm sorry, folks. Can you still